Thanks, Pranay. Thanks, Raminder. Hi, everyone. Thank you for joining this session, and I'm excited to share our experience with Tanzu in the last couple of years that we have worked on. So my name is Varun Sidana. I am having more than 14 years of experience in IT, and I've been associated with VMware for more than 4 years as a TAM. Currently, I'm based out of UAE, and I hold some relevant certificates with respect to Kubernetes. I have CKA, I have BCP on app modernization, and also master specialty on cloud native. With me is Sam Edric, my colleague. So Sam, over to you.
Hi team, thanks very much for joining the session. And this is Sam here. I have over 8 years of IT experience, and I've been associated with the VMware professional services for close to 6 years. And yeah, currently I'm working alongside Varun at the UAE. So I've been involved in this app modernization journey for quite some time. And I would like to share my experience today on how exactly we help customers to modernize or to migrate applications from Monolithic to modern application platform. So yeah, I'm excited for this session as well. So I'm giving over to Varun to start the session. Yeah.
Thanks, Sam. Yeah, so we'll be covering. We'll start with the basics of Kubernetes and Tanzu. We'll do a quick bird eye view on the Tanzu portfolio, and I'll cover high level of vSphere with Tanzu, TKG, and Tanzu Mission Control. And then Sam will cover the architecture along with the add-ons and extension that we have. And the most important topic for today, which is the life cycle of converting the legacy or the monolithic applications to microservices, which we also call as modern apps. We'll not go much deep into the application stuff, but this session will help you in knowing the strategy and how to approach towards modernizing your applications. So we'll be sharing the experience and we'll be sharing the strategy of how do we do it. And at the end, we'll have some time, if possible, for the Q&As. Yeah. So starting with the basics, we all, a lot of us, we have gained expertise on Kubernetes and containers. But for the larger audience, I'll cover some very basics of it. So we know what is container. Container is a little different from the virtual machines. In virtual machine, we have the whole operating system on which we install the binaries and we install the applications. However, in containers, we don't really need a whole operating system. We just we just need a container runtime engine like Docker, and we install the required binaries to run or to support that application or part of that application as a microservice. So that's basically a container. And why do we need Kubernetes? Kubernetes is basically a container orchestration platform. So when in a production environment, when you have already started your journey towards app modernization, you end up having a lot of containers and a lot of applications which are running on containers. So it becomes really difficult to manage the lifecycle and to have a centralized management of all those containers. So we have Kubernetes that helps us with all that. I'll be covering few basic or few very common terms that we use in Kubernetes world. So starting with pods. Pods is the smallest deployable unit in Kubernetes that we work on. So here you can see in the screenshot. This is just an example of a YAML file where we are deploying a pod with an image called Nginx, and the pod name is also Nginx demo. And image is getting pulled from the public repository, and it's exposed on a container port called 80. So this is a declarative way of deploying a pod where we use the YAML files, but we also have imperative commands in Kubernetes that we can run and directly deploy any pods. So pods is basically the smallest unit. It will contain, one pod can contain one or more containers, and it starts and stops together. So here you can see it's a node. Basically, all the pods that you deploy, they run on a node, and node is where the pods will get the resources from. So We deployed an Nginx pod. So you can see the Nginx pod is running on a Kubernetes node with an image version and exposed on port 80. And you can have multiple nodes in a cluster, and all nodes can have multiple pods, and each pod can have one or more containers. That's the basics of deploying pods in Kubernetes. And then next we have something called namespace. Namespaces can be somehow related to the resource pools that we have in vSphere world. So it's like it's the boundary of resources and authorization. And namespace basically it's a methodology through which we can group the resources. We can group the resources from a cluster, and the namespaces can span across nodes within a cluster. The other important point in namespace is that within a namespace, whatever resources name you have, it has to be unique. But within a cluster in different namespaces, you can have same names of the resources. So it's basically it's a boundary of the resources and authorization in a Kubernetes cluster. Then coming on to the networking part of Kubernetes, we have CNIs, the container network interfaces. These are the plugins that are available that we can use. There are many available in Kubernetes, but with respect to Tanzu Kubernetes, we have predominantly the two CNIs that are available, which are called Entria and Calico. They are the network providers for Tanzu, and I'll just cover a few types of connectivities and the networks that we deal with in Kubernetes. So first and foremost is the pod connectivity. Whatever pods you deploy, Kubernetes creates its own internal network, flat network, which helps pods in connecting to other pods within the clusters. And then we have, so we achieve the networking using something called service in Kubernetes. We deploy service and we associate with the pod. We expose the pod on that particular service using a port. And the services can be of different types, like cluster IP, node port, and load balancer. So cluster IP is something that is used when you need the connectivity within the cluster between the pods. And node port is something when you need the connectivity outside the cluster with the other nodes within the cluster. And these things can be achieved using the plain CNIs that are available as an open source. Next, we may need load balancers for our pods that we have deployed if the application requirement is there. Sorry, was that a question? I guess somebody has to mute himself.
Yeah, go on. Sorry
okay.
that.
No problem. Yeah. Yeah, I guess. All right. So the next is load balancer. For load balancer, we need some extensions or some add-ons to use. So most commonly, we use NSXT. If NSXT is not available, you're running the basic version of it. You can make use of NSX Advanced Load Balancer, which was earlier known as AVI. And we have the open source HA proxy as well. This helps in providing the load balancing capabilities for the containerized applications. And then we have something called ingress. This is needed when you want to expose your applications. When you want to access your applications or your containers using HTTP or HTTPS connectivity. So it helps in providing the SSL termination. And we have third-party ingress controllers available. For example, Nginx we have. And then there are network policies that you can define to control the connectivity between the pods. So network policies will help you in kind of achieving the microsegmentations between the containers. So that's about networking. And then the most common term you would have heard in Kubernetes is kubectl. That's the command line tool that we use to do almost everything that we want. So here are some of the examples of the commands that we run, like kubectl apply. This helps in deploying or in deploying anything that you have defined in the manifest file, that is the YAML file. And you can you can deploy multiple, you can use multiple files at a time to deploy multiple units that you want. You can use the whole directory as well. And then there are a few other commands like cordon to put a host in a maintenance kind of a mode, not the host but the node. And if you want to evacuate all the pods from a node, you can use drain command and uncordon similarly. So these are just a few examples I wanted to show. So that was about the Kubernetes basics, the very basics. I mean, the most common terms that we hear. Now, coming on to the Tanzu, the VMware Tanzu. So basically, Tanzu is not a single product. So it's a portfolio. It's a suite of products which helps you manage your production Kubernetes environment. So in Tanzu portfolio, we have different products to achieve different use cases, like Spring Runtime. It provides the framework of Spring ecosystem, which helps you develop or containerize your applications. We have Tanzu application catalog from which you can choose some of the most commonly used applications. This helps to assemble and containerize applications. And we have something called Tanzu Build Service, which Sam will cover later today. And to deliver the software in secure and automated platform, we have Tanzu Application Service. And as to operate Kubernetes across clouds, we have something called Tanzu Kubernetes Grid. This is platform agnostic, but we also have something called vSphere with Kubernetes, which runs only on vSphere. So we'll be covering TKG as well as vSphere with Kubernetes a little. And to centrally manage the whole whatever environments you have for Kubernetes for Tanzu, we have Tanzu Mission Control. We'll cover this in a little detail as well. And then we have Tanzu Observability. This is powered by Wavefront. So that was about the portfolio, and we also have different editions as far as licensing is concerned in Tanzu, starting with basic, standard, and advanced. So the basic one will give you the most common or the very basic capabilities to manage your Tanzu infra. So from the management point of view, you will use vCenter Server, as it will help you in managing the containers like you do with the VMs. For observability, we have add-ons like FluentBit, where you can forward your logs and metrics. For Kubernetes runtime, we can use either vSphere with Tanzu, or we can use TKG. And for networking, we have Entria and Calico that are the CNIs, but by default, it uses Entria. And we can also use, as I mentioned, for load balancing, you can use advanced load balancer. It comes as an essential addition in Tanzu Basic. And for image registry, you have Harbor, which is, again, we'll show this in the lab as well. So that's the basic, and each edition is the superset of the previous one. So in standard, you get additionally also the access to Tanzu Mission Control standard version. And also you have, for monitoring purpose, you have Prometheus and Grafana dashboards available out of the box. And advanced, being advanced, it has almost everything along with the advanced and the highest version of all the add-ons. So TMC, you'll get the advanced version. Prometheus and Grafana, you'll get in highly available state. We also get Tanzu Observability by Wavefront here. And yeah, some other stuff with the networking, and in image, you also have Tanzu application catalog that you can use. Some other things that you get with advanced are, it helps with the container build, which is Tanzu Build Service that we will cover a little. And development framework, we have Spring Runtime, as I covered in the initial slide. For data services, we have Tanzu SQL, which is kind of an open source database service that you get with this, which uses MySQL and Postgres. Right, so that's the additions, and the three distinct products out of the Tanzu portfolio are vSphere 7 with Kubernetes that we will cover. We have so this basically runs with vSphere 7.0 and above, and it needs vSphere. It cannot run other than on vSphere. Then we have Tanzu Kubernetes Grid, which is kind of a platform agnostic product. It doesn't really need to be installed on vSphere. It can run on AWS as well. And then we have Tanzu Mission Control, which helps in centralize, in provisioning and securing your infra in a centralized way. So starting with the vSphere 7 with Kubernetes, it basically, this is the most basic version of Tanzu. What it's made of is we need vSphere, we need NSXT data center, which is managed by VCF. It's not mandatory with 7.0 update 2 and above, but it's good to have NSXT because it gives you the whole stack of networking that you need in Kubernetes. So vSphere 7 provides this capability where you can run Tanzu basic version, and when you run it, it gets integrated with the workload platform, that is the controllers and the TKG service that gives you the API, cluster API style functionality to run your Kubernetes workloads. So how this is what vSphere 7 with Kubernetes is, and how we initiate or how we start with this is as a VI admin, as a VMware admin, from the infrastructure point of view, what we do is we have an option to enabling the workload management in the UI itself in the HTML5 client. So when we do this, it actually creates a supervisor cluster on top of our NSX, our prepared ESXi clusters. So what it predominantly does is it creates 3 VMs which is having the cluster API functionalities, and this comprises of something called supervisor cluster. Supervisor cluster is a term that you will hear only in vSphere 7 with Kubernetes and not in TKG. So this is what it does, and on each host, it installs something called Spherelet. That is kind of an agent that communicates with the with the Kubernetes APIs. So that's from the VI admin point of view, and so once we are ready with the platform, once we have the supervisor cluster up and running, the development team or the developers can actually authenticate themselves against the supervisor cluster using the kubectl utility. And once they authenticate themselves, they can use their own manifest files, they can use their YAML files, and they can start deploying workload clusters on which they will run their application as in form of pods. And they can scale up as they want once they are on the supervisor cluster. So that was the vSphere 7 with Kubernetes, and now the second one is TKG. That's the standalone. So here, as you can see, this can run on ESXi 6.7 U3 and above, and it can also run on EC2 instances and VMC on AWS. So as a VI admin here, it's mostly similar. What you do is you have the utility called TKG. You can initiate the installation from this command line tool, and it will bring up a UI, and from there you can start deploying the management clusters. I mean, I know it's a high level demonstration of how we do it, because in the interest of time we cannot go directly in deep into the networking, but in the upcoming slides you will see more detailed once we go on the architecture. So yeah, as a VI admin on TKG, you deploy the management cluster. Once the management cluster is deployed, it will have all the required cluster APIs and the agents, and then the developers can, in a similar flow as we saw in vSphere 7 with Kubernetes, they can authenticate themselves and they can start creating clusters as they want, and they can scale up accordingly. Right. So that's about the TKG, and the last, distinct product, that is Tanzu Mission Control. So this is very important and very great product if you have a large production environment where you're running Tanzu workloads. So this helps in centrally, managing a lot of things. It minimizes a lot of manual efforts. So basically, what it does is it gets integrated with all the Kubernetes clusters that you have across the platform, not just TKG or vSphere with vSphere 7 with Kubernetes, or it can actually get integrated with the public cloud providers as well, where you have deployed your Tanzu workloads, and it helps in the life cycle and deploying security policies and all those things, in a centralized way. So how it looks like is, let's say this is a snapshot from the TMC console, Tanzu Mission Control console. So here you can see you have number of clusters that are available that you have added in TMC, and you can see that the clusters are coming from vSphere as well as AWS as well as GKE, OpenShift, right? So all these you can manage centrally, and you can do a lot of things. You can do a lot of monitoring as well from here. So and then these are the clusters. You can actually create cluster groups as well. You can create cluster group, add the clusters based on the business units that you have, and on a particular cluster group, you can go and apply the policies the way you want. So this will help you in orchestrating a lot of things. And similar to cluster groups, we have something called workspaces. So this is the another way of grouping your clusters, but not with the cluster names, but with the namespaces. Whatever number of namespace you have based on the segregation you want, you can add those, and you can group your clusters and apply the changes. Then when we dig deeper in one of the clusters in TMC, you see a lot of details like the resource utilization, allocated CPU and memory, the health state of all the components and extensions, right? All those things you can see from a single pane of glass to all your clusters in your environment. Right, so that was about the basics and the portfolio of Tanzu. Now we can get deeper into the architecture and the application side of the things. So from here I'll give it to Sam. Meanwhile, do you guys have any questions? We can open it for a minute or so. And feel free to post any questions in the Q&A section.
Yeah,
chat.
so audience can put their question in Q&A section, because I don't think that the speaking over the webinar would be possible. So
Okay.
just write your questions here, and Sam and Varun will answer you.
Thanks, Pranay.
Yeah, thanks, Varun.
Yeah, Sam, over to you.
Yeah, you can stop sharing. I can share my screen.
All right.
So I guess Tarun has raised his hand. So Tarun, you have any question, you can put in Q&A section.
All right, so I will start off. We will maybe take the questions towards the end. I'll just start off with the architecture part. So I thought I'll explain today a brief about how exactly the Tanzu Kubernetes grid. So this is like TKG we call. This is a solution that can be deployed across any cluster, any environment. It can be either on vSphere, or it can be on Kubernetes, or it can be on AWS. It can be on VMC on AWS, or Azure, or even it can run on a very standalone like kind cluster, which is on your your own desktop as well. So basically this particular thing, I would like to bring a small topology over here of how it is deployed in a production scale environment, and what are the tools that complement along with it, and how does all these help together in bringing a whole ecosystem where an application can run. So if you see this particular architecture over here, you can clearly see there's something called as a management cluster, and there's something which defined here called as a cluster API. And then if you see there are two different clusters which we have created here, which is shared and workload. Yeah, once the presentation is over, I'll walk you through a small demo setup as well of how this is being deployed. Yeah, due to interest of time, I can't do a live deployment, but I'll walk you through a deployment which has been done. Okay, so basically the whole concept of this management cluster is you are not going to run any workloads on this particular management cluster, but this is the cluster which manages every other Kubernetes cluster that is running over here. So basically this cluster would have, just like any other cluster, it would also have master nodes and worker nodes, but it would not be running any Kubernetes workloads over here, but it will be running things like common applications which are required to be used all across, because there are some configurations which we will discuss again, which needs to be inherited by the other clusters that we see over here. And if you can see that the workload clusters below here, so basically these workload clusters, what they do over here is like they are the ones where you actually run your application. So usually you create something called as a shared cluster, which, maybe you want to run something like a shared service, like a registry, Harbor registry, or any other, open source registry that you want to use across all the clusters. So all the shared components you may put in something like a shared cluster, which is not any different in functionality from a workload. It can run any type of workloads, and you can also run n number of workload clusters over here, and they are easily scalable. So basically you will be invoking an API, or you will be just invoking a command towards the management cluster saying, hey, I just want a workload cluster with so and so specification, where you will be defining all this in a declarative format on a YAML file, and it would scale, or it would deploy the clusters for you in this particular fashion. And yeah, this is a very high level architecture, if you can see over here, so of how this deployment is being done. So basically, if you see this way it is being set up, you have something called as a bootstrap VM. And this particular VM is the one, or it's more like, you can say, a jump server, where you have all the configurations that are required for deploying the Kubernetes cluster. So here you have something, you need to have the Docker running over there, and then these are the tools which are required. You have the TKG CLI, kubectl is common, and then there are some Kaggle tools and YTT tools which are from VMware. And what this does is it deploys
Sam,
something. Yeah.
Sorry to disturb you. I believe that people are not able to see your screen. It is visible to us as a panelist, but a few of the attendees
Okay.
are saying that screen is not shared. So can you please just stop your screen and share it again?
Okay. Sorry, I'm sorry about that. Yeah. Is it
Okay.
any better, or?
Amit Bharti, can you please check whether it is working for you now? Can you please write in? Okay, we can go ahead.
Yeah. All right. Yeah. So if you can see the screen, so this is like how exactly a deployment process, or the stage starts off with. So you can see here, this is a bootstrap VM, is more like a control center, or you can say a jump VM, where you have all the tools required for doing the deployment. So basically, if you see, Docker needs to be installed, then the kubectl and TKG CLI, as well as the Kaggle tools which are required. And what this does over here is, whenever you are doing an initialization, the first cluster you would deploy is possibly this management cluster you can see over here. So this particular management cluster is deployed from the bootstrap machine. And when you do an initialization to deploy this cluster, you deploy something like a kind cluster on this particular bootstrap VM, which is necessary for bootstrapping or for deploying the management cluster. So once the management cluster is ready, it would basically destroy this particular cluster over here. And this management cluster, after it is being ready, it is the cluster which is used for managing all the other clusters. So in case you are deploying workload clusters after this, like it may be a shared cluster or any workload cluster, you will be deploying it from this management cluster. And the storage policies, then your domain which is there available, all this would be integrated along with all the clusters over here. So in case you want to do an authentication, you can do an LDAP based authentication to the cluster. And for any type of storage, or if you need to create any persistent volumes sort of things, you can always use the vSphere storage policy, and the CSI plugins that are available within it would be able to, they are capable enough to understand, the vSphere storage policy. It can be vSAN, or it can be a non-vSAN as well, or any storage policies, and it would it would create the disks based on the storage policies. Then for the purpose of load balancing, what we would be using is the AVI, or in case you do not have AVI, it can even be F5 or Metal LB or any other load balancing. In the case of cloud, it can be the cloud load balancers that are available. So so that's so basically what happens in the case of AVI is, there would be an operator which would be running on every cluster, and this particular operator would be the one responsible for communicating. So let's say your development team is building a pod over here, and that requires a service of type load balancer, which requires an IP from a load balancing segment. So what it's going to do is, this particular operator is going to communicate with your AVI controller, and it's going to say, hey, I have a particular workload which requires maybe a service that needs to be created, or a virtual IP that needs to be created, and it's going to create the necessary load balancing IP, and it's going to assign an IP for that particular thing. And the same thing applies for ingress and things like that. So that's the way this particular thing works. And yeah, if you see the diagram over here, the next part over here is we'll be talking about some of the extensions that complement to this particular thing that we see over here, right, to the Kubernetes ecosystem here. So basically, what exactly these extensions do over here is like when you're running a native build of a Kubernetes or a maybe a vanilla flavor of Kubernetes, you need to have a lot of other tools that complement it. For example, if you want to do something like an authentication, right? So you will have to, in the case of a normal Kubernetes cluster, you may have to just create users, or you may need to create maybe certificates for each user for their login, right? So what exactly does Piniped do over here? Is these are all open source extensions, and what VMware does over here is they have packaged them together because these work very well in an ecosystem, and these are supported by VMware. So if you see the authentication part, it is being handled by the tool called as the Piniped. And here what happens is, when you're creating the management cluster or the initial cluster that we are deployed, the first cluster, we would be defining in the management cluster saying that, what is the identity management provider that we want to use. And it can be either, your Active Directory, or it can be, any other OIDC client that you have. So basically, during the management cluster creation, you will be specifying this particular thing, and whatever is specified over there, it would be carried forward to, or it would be inherited by the other cluster. So what happens during the management cluster is we define the values saying that, okay, this is particularly the OIDC client to which I need to send the authentication tokens towards, or maybe the LDAP connectivity to which I need to send the authentication towards, and that would do the authentication for you. And apart from that, once the authentication is successful, you can define the authorization or the authorization to the cluster by using cluster roles and cluster role bindings, just as is in Kubernetes. So it is like the authentication is handled by the OIDC or by the DEX and the Piniped, and then it is being forwarded towards it is based on the cluster role and the cluster role bindings. The other part is being taken care, the authorization to the resources that are available. And then you have the AVI load balancer. I think we have discussed this a little earlier. So basically, this particular thing is the one which is providing you the load balancing capabilities. But in case you do not have AVI, you have other load balancers such as F5 or any open source tools like MetalLB, which can do it, or in cloud environments, the cloud native load balancers that are available as well. And the next thing I'd like to talk about is probably the ingress. And so basically, the extensions come with something called as Contour. And what exactly does Contour do is like it can define how the external traffic can be routed towards the Kubernetes cluster. So basically, what it does is it looks for any changes in this thing, and like let's say you're defining an ingress for a particular application. So it works based on the data path. That is like for every cluster, there would be one IP address which is assigned for the Contour or the envoy proxy, and then anything it works based on the namespace or the FQDN that you allocate for a particular application. So based on the FQDN and the path, so let's say an application XYZ/1/2 or /3/XYZ, right? And all of these things will be defined in a separate path, and it can route to the necessary pods based on the data path that is specified. So it uses an NV proxy, and it sort of does a reverse proxy, and it does load balancing as well. And yeah, so the Contour, it supports like it's a very lightweight profile, and it's quite simple to deploy, and it supports multiple Kubernetes clusters as well. You can deploy this across multiple streams of Kubernetes clusters, and it can be dynamically updated at any point of time. So let's say that tomorrow today you have an application which has possibly two different data streams, like an application which has a web, and then today you have something like a blog, and tomorrow you may have some other number of pods over here. So you can at any point of time modify the ingress resource to point basically something towards a different pod. And so this is a very scalable solution as well, and it's quite easy to implement. The next part is the registry. So the registry we're talking about is Harbor, and Harbor is basically it is a OCI compliant registry tool, and it is open source. And it can be used for storing the images. It can be used for signing images as well as and scanning the images. So it can even scan images for vulnerability. So basically what it does is, this particular thing is like any of your Docker images that are being created by your developers, you can act as a centralized point where you can store these images for the users to, so it can be pulled by any cluster. So basically, if you want to run some pods on any of the clusters over here, you will be using that registry as, where you have your offline store for all your Docker images to be present over here. These can be versioned over here, and it can also be, um, create multiple versions for different users, or you can create like separate projects for each of your team over there. And you can also run scan for vulnerability checks over there. We'll show a small demo of this at a later stage. Yeah. And then we have backups. We have a tool called as a Valero. So this particular tool is something which can be used for running a backup. So it does depend on an object type of storage like S3, or you have some local providers like MinIO and things like this. So yeah, so this particular thing is like it can take backup of your entire cluster, or it can also take a backup of specific namespaces. So in case there is a crash on your cluster and you need to restore the configuration, you can use the Valero. You can either deploy a new cluster and just restore the namespaces that you want, or in case you feel you need to deploy reconfigure the entire cluster based on the backup, you have an option for that as well. And then we come to the logging part. The logging part is handled by the Fluent bit. The Fluent bit is basically, this is something we call as the EFK stack. And what we do over here is like we will be forwarding the Fluent bit to, we will be using the Fluent bit to forward logs to any repository. Like if you're having a Kibana or something like Elasticsearch and Kibana, which complements your logging. So, FluentBit can act as an intermediate to forward over there. Or if you're comfortable maybe using vSphere login site, FluentBit can help you to configure towards login site or to any other syslog server. This acts like an agent which can aggregate all your logs, and it can forward it to the necessary providers. It can provide to a number of providers. And then we have Prometheus and Grafana for monitoring. So these provide something like, Prometheus sort of like gets metrics for you, and it can forward the logs, or it can forward this information to Grafana, which will show it in sort of dashboard for you over there. So this is the way this whole thing works, and I will show you a small demo of how this particular thing looks in a production environment. All right, so if you can see my screen over here, right? So this is basically the, the control plane VM or the bootstrap VM I was talking about. And here is where we run the commands to, create the cluster. So here I've already created the cluster. So I just give a command to get, and the command to initialize will be just, create instead of get. And what it does is it will just show over here the VMs that are available. So basically this is doing nothing much, but it's just creating virtual machines for you from basically a template that you use. So, you are just defining a template over here, and based on the template, it's going to deploy. Yeah, so you have a template over here, which is sort of like, which is customized by VMware, and it comes with Photon, or it comes with Ubuntu, Photon, and I believe Red Hat as well. So you can choose any one of the template, and based on the template that you're deploying, it will deploy the management cluster or the management cluster for you. So if you can see over here, it deploys a couple of VMs, and all the pods that are necessary on the management cluster would be running inside this. So there's something like called as a control plane, and it would have something like a virtual IP, which would be used for accessing the cluster. And so basically what happens is, once this is being created, what we'll do is we'll be creating something called as a workload cluster. So if you can see over here, there are multiple workload clusters which are created. Some in deleting state, but yeah. If you can see, there are multiple workload clusters which have been created over here. So these clusters are being created by using the management cluster, right? And what happens is once these are created, you will be getting something like so you can list all the contexts that you have. So you have 3 different contexts over here. So whichever cluster that you want to deploy to, you can actually, just switch the context. For example, wherever the star points towards, that's the current context. So currently I am working on the Tanzu workload cluster. And if I want to deploy any workload over here, it will be deployed over here. And all these extensions that we talked about, they will all be running inside this cluster itself. So if you can see over here, they will be running as applications within it. And you can see that they are all deployed as packages. And they are basically nothing but pods which are running within the cluster itself. So if you can see for Contour runs as pods over here. And yeah, so so if you see Prometheus or Grafana, all of this will be running just as pods over here. And that's the way it works. And just to show you a demo of how exactly probably the Harbor registry would look like. So this is basically the Harbor registry that we talked about. And so if you can see over here, this is how it looks like, and you can create multiple projects over here. And basically in each of the project, you can create something like, I just created some application over here, and I've created like 7 versions of it. So it's like, your development team, when they're creating a maybe an application, they can just tag the application to this repository and they can put over here. And whenever they're making any changes to their code, they will be creating a new image, and that would be created as multiple versions. And this also gives you many more options, like, you can actually create replications. For example, if you have an existing repository or you have multiple sites and you want to, share your registries, you will be having options to, replicate it across the site, or you want to pull from some other registry which is also already available in your environment, you can also do that. All right. And yeah, that's pretty much on that's pretty much on this particular thing. You can give access to users. You can define something like the quotas that are available for each team. So these are the things that this particular thing helps you do. Next, yeah, we'll move towards the Prometheus. So basically, if you can see Prometheus, right? So this is basically a tool which helps you to collect metrics. So you can write your own queries where you want to collect your specific type of data. And then we have the Grafana. So the Grafana is something like a dashboard. And this particular thing also, you will have options to create your own dashboard. And if you want, or you can use the existing dashboards, which will show you some details about, the Kubernetes environment that you're currently logged into, right? So it shows you like what amount of containers are there, what's the pod that's running here, and those type of details will be present over here. All right, so if you can see, it shows currently this has 55 containers, and I think there's 1 container which is crashed or it's waiting. There's 3 which just terminated, and how much of resources are being used. So this is a live information which is present from the Kubernetes environment that you see running over here. And yeah, so all these things, like, whatever is errored or whatever error we have or whatever pods are running, all these things would be showing up over here. So I think we have a pod which is crashing. So that's what shows up over there. And you can run your own dashboard to define, like, maybe if you want to monitor a very specific application, you do not want the generic applications, but you want to monitor your very specific applications, you can do that as well by, creating your very own dashboards with the queries that you want. Like, you have options to create your own dashboard, and, you can create a panel and you can define your own queries over there. Like, you can create something like, yeah, I have some predefined queries. So yeah, if these are pretty much works on the PromQL language, and if you create something like this, it would show you something like, it would generate metrics based on this that is available. Yeah, so you can see here it shows like the data for the pods that are available. So these are all the pods that are running, and you can create based on the values that you define. So that's pretty much on the demo part of it. Maybe the next time when we have, I can show a higher demo, because due to the shortage of time, we still have a lot more to cover. And the next part is more about the app modernization strategy. And this is more likely to be theory. And so here we are going to talk about what exactly we do on the app modernization, or how exactly we are going to help customers or help people to move from the monolith applications to run on the Kubernetes platform that we saw, how we are going to leverage all the tools that we saw till now, and we are going to help or move the applications to run towards it. So if you can see over here, right? So when you see a particular application, there can be like multiple types of applications. So when you're moving towards a cloud native approach, the whole idea is moving towards the cloud native environment is to ensure that it can run on any platform. It doesn't depend on the platform. So basically, if you have a container image and you are able to run it on your vSphere with Tanzu or your Tanzu Kubernetes platform, and tomorrow you want to move it towards your cloud, you should have very less difficulty. It should be platform agnostic. So that's the whole point of it. And when we are moving towards application, we see multiple applications available. So some of the applications, for example, may be very old and you may just want to retire them, right? You may not want to, use them anymore. So it's very important to understand which applications, probably are no longer helpful in your environment and just maybe retire for a newer application. Then there are options like some of them may not be convertible. For example, you may have some database or your Active Directory or things like these, which are very much integrated in the ecosystem, and possibly they cannot be converted. So, we are just going to run those applications as is, and we are not going to, we are just more or less retaining the application. Some of them, maybe you may want to rehost them. Like, for example, they may be running in your environment and you may think that, okay, they may need to run on a cloud or a different environment, and, maybe they're suited to run. You may want to move to a different platform. And then there's something called as replatform. Replatform is where we are focusing on, where we will be taking a monolith application, we'll be running some tests on it, we'll be going through a strategy over here where we can convert these applications to probably run on any cloud native platform. And the last part is where we will be doing where we may be seeing some applications where you may have to do a rebuild. For example, you may see that these applications may not run particularly well on maybe with the current level of the code, and you may need to rewrite the code, or the developers need to rewrite the code so that they can run on the cloud native platform. So these are decisions that needs to be taken based on analyzing each individual application, their business use case, and how they are helping, how critical they are in your environment. So basically, when it comes to the app modernization strategy, the first thing that we do is something we call as a discovery workshop. So this particular workshop, or the discovery workshop, what we normally do in this phase is we try to understand from maybe the end users, or from the from the application developers, what exactly is the portfolio of this application, and what are the risks that are involved in migrating this particular application, and what are the assumptions on which this application has been built, right? So these are the things that are being taken into account while we are defining, while we are looking for, while we are doing this discovery workshop. And we try to understand, like, what exactly are the exact function of this particular application, what are the dependencies of this application. Like when we consider an ecosystem of an application running, the application may not be just running on its own. It can be, it has dependency on multiple applications, and also there are multiple applications that are dependent on this particular one. So it's important to understand these things, and we clearly define a scope for the application before we proceed to the next level. And there are some tools that we also run to understand if an application can be this thing. So these are all open source tools. If you can see here, Cloud Suitability Analyzer and dependency checks, and there's code analysis. So basically, if the developers, and so this is basically run on one of the application, and we can see here there are some results which are given over here. So basically, it's like these tools, when they are run, they would give you something like a report which says, is the application probably suitable enough? So basically, these are things which are run by your developers, and they can actually run this on top of their code base, and they would give you something like, is this application suitable to be run on a cloud native environment? Or possibly, if you're going to migrate it to a cloud native environment, it may not always be that the application would not just run, but there may be a lot of risks as well of running. For example, we've seen some codes where there are many loose ends, like the passwords are being exposed, or the way the application is written, the the environmental variables, they are not flexible to be modified. And so the whole idea approach of having a containerized image is to give very less work to the developers when they go about developing in the future, and to have it to be easily streamlined. That is like the passwords, for example, they may be stored as a secret. For example, the JSON files can be stored as a config map. So these things are decoupled from the code, so they do not require to every time they need to make changes to this, they don't have to repackage the entire application. So these things are being checked by some of the tools that are present over here, and these tools give you some sort of reports like you see in this diagram. And based on that, you can take a decision whether your application would possibly run on a cloud native environment or not. And the next phase is something we call as a navigator. So this navigator phase is basically where we run deep dive sessions to generate recommendations that your software has risks, or this is like you are having a high level this thing with all the stakeholders that are involved. And this phase involves probably people who where you would be discussing not just the functional defined requirement of this application, but also something like non-functional requirements, like a roadmap for the application, how exactly it's going to be implemented, what's the expectation of the application after it's re-platformed to the new platform. And and we also discuss here about risks that are involved, like in moving to this, what are the dependencies are there, which other applications are probably dependent on this, and who are the customers involved on this. So this is like a huge like a workshop where we discuss all these things associated with the application. And then we go about the architecture process. So basically the architecture process is like we have to define a blueprint where we define what's the system's requirement, then we need to map the components. So like if you take a very simple application, a recent example which we've been working on, we had a .NET application which needs to containerize which we need to migrate towards the cloud native platform. So what we needed to do here was we needed to figure out how many services needs to be there, each of the application, how exactly they can be divided into multiple services, what are the dependencies for each of them. So when they're running probably in a non-cloud native or the monolith environment, all the dependencies may be jumbled. So we need to segregate the dependencies. Then how are they going to fit in the cloud native environment? How are they going to be exposed? Do we need to use a load balancer, or maybe do we need to use a an ingress controller? How the communication between the services is going to be taking place. Like you may want to use something like an API gateway there, or maybe something like a service mesh where the communication is being handled between the services among themselves. And then how do you want to store your passwords? Maybe you may want to use them as secrets. And then your config maps where you define your environment variables or your JSON files. So these are the things that you do during the mapping phase. And then based on this, you create a design saying that this is possibly the strategy for moving this application. Then once the application is being migrated completely, it's being handed over to the support team. And the last part I would like to cover over here is the Tanzu build service. So basically, whatever we talked in the previous slide was more about the conversion process. Now the whole part is this particular tool called as a Tanzu build service. It's basically a tool which somewhat complements. It's not a replacement for the CI/CD pipeline, but more like it's something which complements the CI/CD pipeline. So here I've used an example of using Azure DevOps, but it can be any other pipeline that is being used. It can either be it can be maybe Jenkins or any other tools that you use in your environment for using the CI/CD. So basically, in a normal Kubernetes or in a normal application development environment, what would happen is, when a developer is possibly creating a new code, or when he's making a change to a code, he'll be creating a branch and possibly committing the changes towards that branch. And then there would be any CI/CD tool. Maybe here it's Azure DevOps, or it can be Jenkins, or anything that would probably be used for, they'll be using for maybe packaging that application. So here what we do is, in the case of Tanzu Kubernetes build, so basically this Tanzu build service is a tool which has its own cloud native build packs. So basically, these build packs are like dependencies that are required for maybe an application. You can call it somewhat like modules that are required for, let's say you have a Java application, the Java dependencies are being kept together as build packs. So, normally when you need to create a Docker image, you may be using a Docker file, but instead of using a Docker file, here you can use a Tanzu build service, which would have all the dependency packs packaged here. So what you can do is, you can create something like a pipeline over here, which will trigger the Tanzu build service once, it sees like a change in the code or something that's present over here. So the Tanzu build service can automatically build up, it can rebuild the container image for you based on the changes that are made using the cloud native build packs that are available. So there are a few languages for which the build packs are available. And I think there are some custom ways in which you can create your own build packs as well. And once the new image has been built, what it does is basically it's going to push your new image towards the Harbor registry, which we spoke about. So basically this particular tool is integrated, or the Tanzu build service is integrated in such a way it can listen to changes from your your CI/CD pipeline. At the same time, once it can make the changes, or it can build your images, and it can also save the images in the container registry that you see over here. And once these changes are being pushed to the container registry, you can create something like a webhook on the Harbor registry. So this is something like a trigger you can create, saying that it sends out a trigger towards your Azure DevOps, saying that or your Jenkins or any other pipeline, saying that, hey, a change has been being made, and basically it creates another pipeline where it will deploy the images towards a cluster. It can deploy towards maybe the development and then towards the production cluster. So this is like an entire automated process in which once the developer makes a change to an application, it can traverse all the way, and it can make sure that with minimal effort, the application is directly built onto the Kubernetes cluster, or the cluster, by using this tool called as a Tanzu build service over here. And yeah, unfortunately, I cannot show a demo due to lack of time. Maybe the next session, when we can probably show a proper demo about how this entire process happens. Like, maybe when you make a change and commit the change, how exactly does it run through each of these steps over here, and it would be covered. Yeah, I think that's pretty much from my end.
Yeah.
And
Thanks, Sam.
Yeah,
so basically the idea was, or the point we wanted to demonstrate here was that we guys know what's the flow when we are planning to do a conversion of an application from legacy to containerized. So I think you guys now have a fair bit of understanding of how to approach towards that. And if you're having a conversation with your management or the key stakeholders, you can refer to these slides, which we can share on the group, and you can have some understanding. That was about it, Pranay and Ravinder.
Yeah, okay. So Varun, I have one general question from all the audience and from most of the bloggers. If you can just give us like what kind of like basic like someone want to test this in a lab environment. So what all the minimum components they would need, and what all basic hardware they would require.
Yeah.
If you have any kind of idea, we can share later on as well.
Sure.
Yeah. So the thing here is like, so basically the one we talked about here, the Tanzu Kubernetes grid, which I was talking about, which I showed as a demo in the lab. This is available as a Tanzu Community Edition, TCE. So basically this can be deployed on any environment, and it does require very minimal resources. You can basically even try to run it on your even on your laptop as well. If you have maybe 16 gigs of RAM, that should be more than enough. The Tanzu Community Edition. And that has almost all of the tools that we spoke about, right? We spoke about Harbor, we spoke about Contour, we spoke about, I think Avi doesn't come with it, but you can use some other open source load balancer for it. There's something like Metal LB, and I think the installation is pretty simple. It does a similar sort of job. And the other tools like Prometheus and Grafana are open source as well. So all of these tools can be deployed pretty much simply using the Tanzu Community Edition itself. So this is not for the one with vSphere with Tanzu, and this does not require any NSXT for networking. It just requires basic network to run the nodes, and you can run it even on your standard vSphere cluster, or you can just run it even on your desktop as well if you want to just do a quick test of it. And for the vSphere with Tanzu, there are two ways of deploying the vSphere with Tanzu, but that requires a complete stack of vSphere setup, and it would require it creates something like a supervisor cluster and a couple of nodes, and you can create that also without the NSXT requirement. But however, if you want to use the entire feature, like so basically whatever we spoke over here about ingress, and we spoke about load balancer in vSphere with Tanzu, all those capabilities are coupled directly on the NSXT. So if you're creating something that requires you to run maybe a load balancing solution, it would automatically leverage the vSphere with Tanzu, or it would automatically leverage the NSXT for deploying the load balancing component that we need, or any ingress resource if it requires. It would automatically leverage the components that are available on NSXT for performing this particular thing. So for vSphere 7 with Tanzu, if you are using the supervisor cluster sort of setup, yes, definitely the using NSXT is the right way, and probably that's how it's been set up. But there are options for setting that up without the NSXT by using the NSX advanced load balancer, the RV, and the open source tools as well. But yeah, it's not as straightforward as maybe the Tanzu community
And to
edition.
test it completely, you may need a good amount of memory and CPU resources on the machine.
Yeah.
Yeah.
So Tanzu community edition is the easiest way, and it's very platform agnostic. It doesn't require it can run on anywhere, and it's the easiest to set up. You can try pretty much easily. I think there should be it was released, I think, a couple of months back, and there are a good number of blogs available as well to help how you set them up, not just on production environment, but even on your just any normal machine as well.
Okay, all right, yeah. Thanks, Sam. Thanks, Varun. So we have two more questions left. One is in Q&A section and one in its chat window. So can you please answer those as well?
Yeah.
In Q&A, we have, can we make Active Directory DC in container 2?
I don't think so. Active Directory, currently I've
not the
not seen
DC
at least.
itself. Yeah, but we can enable the other directory services we have that we can integrate with the containers. But yeah, the Active Directory DC itself, if it can be containerized, if that's the question, I don't think so.
So there are a few things that we normally see while doing containerization, just to give a thing. So it's like basically the target here is mostly the stateless services. So stateless is like anything that does not save the information or does not require any binding, particularly like maybe it has a binding to the IP address or binding to the environment. So these are the things like maybe a MAC binding, because what happens in the Kubernetes environment is like once the pod is being destroyed, everything that goes to the state is being destroyed. Now, there are some things like stateful sets which are helpful in overcoming that. But the whole idea is like, the initial part is like when we are looking for it, we look for the web application possibly, and then maybe, any Apache or any applications that are running here. That's like the second part. And usually the database or, the third tier, which are the backends, these are the things we leave it to the last, because these are things which, because the database, it's not like it cannot be run, but it's like to migrate a huge chunk of data, there is no such thing as a direct path where you can directly migrate all the components or everything in a seamless way to a DB solution that is running cloud native, maybe a solution that can run on a cloud native platform, right? So so usually in a normal environment, or when you're looking, maybe if you're looking for starting with your app modernization strategy, not your domain controller or your database, these are not the parts that you will be checking first. The first part you will be checking is possibly your web server, your application server. And so that's again where the very important part of decision making takes place as well, because you want your application to be sure that they are not saving any static data on that particular thing. They have to redesign your application in a way that the static data is either sent towards the persistent volume or the containers does not probably need it. Hope that answers that.
Yeah, thanks for explanation, Sam.
Yeah.
So
okay, that's something about vRealize automation. To know the real use case of this if customer
Are you going to take that one as well, Sam?
I'm sorry, I did not get that question.
Yeah, we can get back on this one.
Yeah.
I mean, the use
Uh,
case
But I
of
didn't
using
get the
Tanzu
question.
with
If you
VRA.
can... Oh, okay, with VRA.
Yeah,
Yeah, I guess there are some integrations.
there are
but
some.
I'm
Yeah,
not
we can share.
not very sure of it. I
There
can
is a
check on
pretty
it.
good, decent integration of Tanzu and container services with the VRA 8.
Yeah.
I think the
Yeah.
question is specifically to 7. Maybe Tarun, you should look at 8. Integrating 8 with Tanzu to get the full utilization and realize the full use cases of Tanzu and integration with VRA as well.
Yeah, and in fact, the VRA 8 itself is containerized with version 8 and above.
Right.
I mean,
Yeah.
when we install. Yeah, I think we don't have any more questions left.
Sure. So I think we're already over time. I saw a couple of requests, people wanting to, unmute and they want to talk. If you have time, if you want to stay back, I'd go ahead and unmute them and maybe they can ask their own questions. Some of the people know you from your past, right? So I think.
Sure. Yeah.
Sure, go ahead. Yeah.
One by one, Dharmendra, you on first. You can unmute and you can go on, ask your question. Dharmendra?
I guess he asked about the lab and that's already answered.
Okay. So anybody else who wants to unmute, ask a question? We already over time. So if you guys want to stay back for Q&A, you feel free to unmute and ask those questions as well. Okay, so I think I see Dharmendra is unmuted, but we don't hear him, right?
Yeah, hi sir. Actually, I have raised the concern for the practice. I have already got the answer.
Okay.
Thanks.
All right. So I think we don't have any more questions, and I just want to thank you, Varun, and thank you, Sam, for coming in over a weekend before the start of the weekend, long weekend. I'm actually in a weekend mood, so saying that. Yeah. So thank you for that, and I want to thank everybody from the community to come in and participate and make this a very wonderful session. I hope these queries have been addressed, and we'd basically be looking at some feedback from you guys so that we can improve the sessions. If there's anything that you want to see, you want to hear about a particular topic, feel free to reach out to us, give some feedback to us, share your information with us, and so that we can go ahead and improve these sessions in the future. Before we conclude, over to you, Pranay. Anything that you want to talk about?
No, so that's all. So thank you so much, Varun and Sam, for giving your precious time, and thanks as well to all the audience who joined the session during this vacation time. And we had a couple of plans for small goodies, but yeah, due to the virtual concerns, so that may not be possible. And yeah, once we meet out physically, then definitely we'll hand it over to the all the audience who will be available there. So next time, we are next year in 2022, we are planning for a few more sessions, and we would be planning for some VMUG Advantage coupons for that, and we'll let you know about our plan. Yeah. So that's all from my end. Thank you so much once again.
All right. So thank you everybody for joining in, and wish you all a wonderful 2022. Hope we get out of this virus, Omicron, we leave this behind and we don't see that in next year. Wish you all a very happy new year.
Yeah, wish you all a very happy new year, guys.
Right. Bye-bye.
Bye.
Thanks everyone. Bye-bye.